Okay, so what we're going to talk about today is the novel hypothesis that we live in a binary star system, and that STAR CORE ZEUS is the remains of the companion star of the Sun, and it blew up 4.6 billion years ago at the formation of the solar system. I'm also going to explain what Pangaea is, because it's not a supercontinent, and I'm also going to explain how the moon formed, which is an area of controversy at the moment, where there are a lot of moon formation theories, but unfortunately none of them actually fit all the data. And so at the moment it's a major conundrum to explain where the moon comes from. Okay, so to start, I've shown the slide before. This is the local environment around the solar system. The crosshairs are where we are. This is 3,000 light years from here to here, 3,000 light years from here to here. This is in parsecs, that's why they're smaller numbers. So that's 6,000 light years across. That's a very big explosion. It's a very old explosion. And this is where the gas clouds from the exploding star ended up after 4.6 billion years. Okay, today, Zeus is a cold object. It doesn't radiate much light. These are cooling curves. This is fairly well established for white dwarfs as they cool down. Now, heavy white dwarfs actually lose heat very slowly, so they are still visible, and that's why we can still observe them. But much smaller white dwarfs, that is degenerate matter, this is not a neutron star, this is not a black hole, it's just degenerate crushed matter. When it's about 10% of a solar mass, it's a body about the size, 2 or 3 times the size of Earth, and has enough time over 4 billion years to radiate almost away all its heat, so it's no longer visible. However, STAR CORE ZEUS is a magnetic object. It came from a magnetic star, so it generates a radio frequency output. In addition, it's not totally cold, and recently a space telescope went up for detection of infrared. That's the Wide Field Infrared Survey Explorer, which is still in business under a new title, NEO-WISE. It looks for near-Earth objects. And in fact, at the center of the radio signal, you can find a hot object. Well, not that hot, but it's about 100 Kelvin object. So these are the images. This is the radio image. And there's actually 2 radio images here, and you can see they're not in the same place. And that's really interesting, because that means that you're looking at an object which is moving. But it's not moving because it's in a sort of a close orbit. It's because we're moving around the sun. This is a parallax effect. But from that, you can estimate more or less how far away it is. This infrared source corresponds to that source, but this is on a much more larger scale. I mean, a more detailed scale. Let's go this way. Okay, so just to give a very big picture of what we're talking about, this is the solar system out to the orbit of Neptune. That's 30 astronomical units. If you are where we are here, and you look towards Sirius, you're actually looking 8.6 light years away. So this is a sort of a diagram showing you the direction. It's not showing you how big the orbit is. It's not an 8.6 light year orbit. The orbit of the star core is about 500 astronomical units. That's 500 times the distance from the Earth to the Sun. At the moment, the star core is about here. So the line of sight takes you over to an area of sky between Sirius and Orion. And in fact, you can get that on Google Sky, and you can even, there's something there. I don't know what it is. You know, but there's definitely something there. Maybe that is to do with the object. Now, when we finally observe STAR CORE ZEUS, it's going to be a dark sphere, and it's going to be surrounded by a torus of dust. And it travels in a very eccentric, steeply inclined orbit. That means it's got a stretched out orbit like a comet, and is approximately perpendicular to the plane of the average orbit of all the planets of our solar system. The Sun and Zeus actually orbit each other, so our whole solar system is in motion, orbiting the common center of mass with Zeus and the Sun, because Zeus is the lighter body. We only wobble a bit, but over a 4,000-year period. The important point is that I think Zeus has got so close to the Earth from time to time, it's been responsible for serious geological changes on our planet. So not only did it get close enough to pull up mountains, it actually got so close it once ripped off the surface of our planet. And it's due back, 2372. So we're still going to be okay. We've got some time to make our plans. Right, this is a simulation, but it just gives you the idea. Right, well, this is actually 9 months speeded up. So what it's doing, I'll do it again so you can see what's going on. It's coming over the north pole of the sun approximately, and then it's crossing the Earth orbit just here. And it comes through very quickly. It's doing about 50 kilometers a second at that point. The reason the solar system is still sort of intact is because the forces are acting when it's coming on that side and that side are approximately the same. So it causes us to wobble, but we basically carry on in the same disk. But there's more modeling that needs to be done on that. So that's just a very basic introduction to what the concept's about. That is, we live in a binary star system. It's a binary star system with a condensed object, which is almost invisible, but it does have a radio signal, it does have a heat source.